Hey, good evening. So this is a continuation of our discussion on valuation and rates of return, right? A while ago, or the first video that we had was on bonds, and then now we're going to go to the one for stocks. So on the stocks one, think about it this way. Your stocks will give you dividends. The question now is, what will be the right amount that you would need to use to pay for the stocks that you would like to buy that provides you dividends? Now, the dividends can be constant, meaning that, for example, for each share, it can be $10 every year until you have it in perpetuality, right? In perpetuity. So in so you will have it until you will earn $10 every year until such time that it's able to declare dividends. Now there are times wherein a company will be able to do, say, constant amount of dividends, but later on there will be a growth, right? So we're going to explore that. So it's not only $10 each year, but it can be $10 for the next 5 years. Then you're estimating that the company would go big and might have a 20% jump, or depending on. So what will be a good price for that stock? That's basically what we're trying to do, uh, talking about valuation. So let's take a look on this one, valuation and then preferred stock. So we have common stock, we have preferred stock. More likely than not, it would be the same way of calculating it. But here for preferred stock, makes representation in perpetuity about the dividends that you will be having. So there's no maturity date. Unlike the one for bonds, right? You would actually need to cap it out with a number of years. And there's a time value. Here, there's no time value because it's going to be, as long as the company exists, you're going to get the bonds. Now, let me go straight up on the calculation. The calculation looks like this, a bit a lot, but we'll make it easy, okay? So for example, let me break it down by using it. Okay, there you go. So this will be the price of the stock. Price of the stock. Right now, there's a letter P small, which is the preferred stock. And then what you have as a numerator is actually the dividends for the preferred stock. So this can be a common stock or right now as a preferred stock. So the denominator right now is actually the numerator right now is actually the annual dividend. Can be $10 a share, $20 a share, $2 a share. And then K is the required rate of return. It's just that there's a letter P, a subscript, which is representing for the preferred shares, right? And then now when you think about it, you have one, two, three as your period of time. Before it was represented by letter N, or the number of periods, or letter T, the time, right? And then here you have infinite, right? So you have, oops, you have that which is infinite or infinity, right? Uh, that's why to simplify this one, because you could not do that infinitely, right? That's a lot of ellipses and then a lot of how many years. This will be a more usable formula. So the dividends annually as a numerator, then your denominator will be um, the interest rate or the rate of return. Then that will be your amount of the preferred stock. So simply said, if your preferred stock earns a annual dividend of $10, then divided by 10% rate of return. So it's basically $100. So that's the simplest thing. It's actually a simple calculation compared to a present value calculation when it comes to bonds. Why do we need to do the bonds with a longer formula? Because it's time bound, right? This one, it happens in perpetuity because unless the corporation closes or has a going concern, the company actually um, basically is there forever. That's why corporations are there forever unless there's a termination or a liquidation of the business through bankruptcy. Now, here, what we're trying to do is that similar to what we had before on bonds, the rates would actually change. It can be higher, can be lower. Right now, if the rate is higher, the expected rate of return, the value of the stock is actually on the lower side. And then there are reasons to that. So we're going to explore that similar to how we did scenario one, two, and three for bonds, but using the same formula as well. I just want to make sure that the scenario actually makes sense for it. At the same time, we will go through wherein what if there will be some changes in your, there's a constant growth, meaning that not only that you're thinking it will be a 10% return, but you know that the company or the dividend will grow. That's why there's a factor here that you need to multiply it with your dividends. So it's not a standard $10 dividends all throughout the years. There is a growth to it. So how do we account for that? So I'm going to stop there and then move to the Excel file, which will be better represented when we go here. I know, guys, okay. So I have one, two, and then number three on this side. Some of them you can see that I pulled out from our PowerPoint, and then some are actually I added so you have some calculation, right? We are still on the same file on week number 6, but now it's actually a second section, which is the stocks. A while ago, we were on the bonds. Now we were on the stocks. So I want to make sure that that's clear. Now, let's go to the first scenario that we're trying to take a look at. There are no growth on the stock, no growth on the dividend. So the basic principle is that, just big, okay? And then we will size it properly. So not too crazy. Kind of, guys, okay. Collapse the ribbon. So we have more space. There you go. So no growth stock, no growth in dividends. So basic principle, when dividends are expected to remain constant, basically no growth, the stock price is simply, which is the valuation that we're trying to compute, is simply the present value of the fixed dividends. So dividends, D1 is the fixed amount or the current annual dividend, which is fixed. And then what we're trying to compute is 4 is the current stock price by dividing it with the current rate of return. So we have KE. E will be for equity or for stocks. We have KP, subscript P, because it's preferred stock. So it's the same. K normally represents rate or required rate. Sometimes you would see I because they want to make sure that the required rate of return is different from the interest. Sometimes that becomes R. R will be a rate other than the required rate. So we have in finance certain letters assigned that would actually make sure it's consistently applied, right? But so letter E pertains to equity. That's why it's stocks, right? Stocks are equity instruments. So just to be sure to explain it properly. Now, so if I have here a $10 annual dividend, and then your required rate of return or expected return from the shareholders or investors or stockholder is 10%. So the value of the stock, which is the one that we're trying to solve for all the scenarios, is basically $10 F23 divided by 0.10, which is this formula, basically $100. As simple as that. So not too crazy compared to bonds, right? And then this is our baseline scenario. Our baseline example is $100. I just copied it because I want to make sure that we can highlight it against and compare against scenario 2 and then scenario 3. So investors require 10%. You know, it's actually $10 divided by 10% is equals to 100. Good. Now, what if, similar to what we have on the PowerPoint, but I just now put it in Excel, the investor require a higher rate at 12%. The formula would not change because the formula is still your the amount that we have right here. Let me just make sure I have it here. I'll press F2. It's now $10 of the annual dividend divided by the 12% rate, which is now 83. Okay. So on a higher rate, it became now $83. So now what's the question? What happened? If it's a fixed dividend, then it's actually a stock, no matter what how the company does or how the company shifts, as a holder of the preferred stock, you will always receive the same dividend, right? That's the basic premise. But what if the required rate is actually higher now, right? So a higher rate demanded equals a lower price that you're willing to pay. If the rate is actually 10% and then the value, the expected is actually 100, right? But here, if the rate is actually higher demand, you're willing to pay lower. Why? The investors are demanding a higher rate. So from 10% to 12%, they're they aren't willing to pay as much for the stock today. Why? Because the dividends are fixed. So the dividends will always be at $10. So the only way to achieve a higher rate of return is to buy the stock at a lower price. Similar to how we looked at it on the bonds, right? Here, hey, you know what? I'm always going to get $10 as dividend. And then, but I need to get a 12% rate of return. It would mean that I need to pay a smaller amount for the stock, similar to how we did the bonds, in order for me to get that 12% rate of return, or the IRR, or basically the yield to maturity in relation to bonds, but return in relation to stocks. So that will be 83. It did not change the calculation. It's still the same. It's actually the $10, the annual dividend divided by the rate of return. But you can see there's an impact on the amount. It's actually an inverse relationship, right? The higher the rate of return, the smaller the amount that you're willing to pay for it. Now, let's take a look on the scenario wherein the required rate of return is actually 8%, and then the value of the stock becomes higher, so inversely proportional, right? So why? Formula-wise, same thing. $10 divided by 8%. So let's take a look at it. When investors demand a lower return, they are willing to pay more for the stock today because the fixed dividends, which is $10, provide enough income to meet their return expectation. In other words, the higher the price, the higher stock price equals lower return because the same dividends being paid out regardless of how much was spent on the stock. This happens mostly when there's a interest rates are lower or investor believes that there's a low risk for the company. Similar to how we look at the bonds, it's actually the reverse impact or effect. Now, I'm gonna go here. No growth stock, it's always the same dividend. Easy, dividend divided by the rate of return. I'm going to now move to number two, okay? The number two situation or scenario or set of circumstances here. It's a growth stock, meaning now we have a increase. So that's why we have another variable, G, which is the constant growth rate in the dividends. And then now we have the dividends here. So a while ago, I'll make sure that we can show it in the PowerPoint. Because when you look at your PowerPoint, there's a growth rate that you need to apply on the dividends, but you need to do it in infinity. This one is not a usable formula, similar to how we did it before, right? The usable formula would actually be, or simplifying it, is to say, hey, here's the required rate of return minus the growth rate. So this will be a lower rate. And then if you divide it with the numerator, which is the dividends, basically it's going to be higher. In math, it will be the case, right? A lower base, and then you have your dividend amount, same, then it will basically gross up higher amount. So you would basically pick up the growth itself. I'm going to hide that. So how does the formula work? It will be Y23 is the dividend. So what's the dividend? Y23. And then the dividend is $2. So that's $2 divided by 12%, which is the expected rate, which is the KE, and minus the growth, which is actually 7%. So 12 minus 7 is equals to 5%. $2 divided by 5% is actually our $40. I'll do it the same way. $2 divided by 5%. 40. And how did we do the $5 is basically 12% minus 7%, which is K minus G. So again, in a way, math-wise simple. So it would mean that the amount or the valuation for the stock that would pay dividends of $2 in perpetuity with a expected stockholders rate, rate of return of 12%, and you know there's a growth rate for the company because there's a constant growth now, constant growth. You're willing to pay 40 now. So if you say, but what about what happened to the $10 a while ago? Let's do a change to $10, and then this is 10%. Right? The expected rate, I'm just making it similar to what we had before. Well, annual rate is $10. And then the expected is 10%. Instead of paying 100, because there's a growth now, constant growth, the amount is actually higher. Even if I make this 5%, the amount is actually higher compared to a no growth dividend, a no growth dividend type of scenario. Okay? So I wanted to make sure that we can make some tweaks on the first one compared to the second one. And make sure we can see it side by side. Hopefully it's not too small. There you go. Move it here. $10 of annual dividend at 10%. $10 of annual dividend at 10%. No growth rate. Go to the growth of 5. I'll pay double. 300 is the price of the stock. This one is 100. And then I'll return it to the same $40. Just want to make sure that we can actually show some comparison. So you pay twice as much, right? If it's similar, but with a constant growth rate for the dividends at 5%. Now, on the second section, before we go to number 3, I wanted to show similar to what we did in week number 5, right? The same formula here. If I try to solve for letter K, which is the rate of return, what will happen now, the formula would be the dividends divided by the stock price plus G would actually be your growth rate. So basically, it's the same here, but we're trying to solve for letter K, which is actually the rate of return. Let's do that. So it's basically the dividend of $2 divided by the price that we're willing to pay, that we're willing to pay for the stock that would have a constant rate of 7% growth, plus the growth rate of 7% is equals to 12%. So I'll do it again. So it's $2 divided by 40. Basically, that's 5%, right? But I am adding on that one the growth rate of 7. That's why it became back to the growth rate. So it's just deriving the formula. I want to make sure that we can show that to you as a calculation. It makes sense by deriving it, but want to make sure that we can do the math as well. Now, The last one for us on the stock is that what if there is a growth on the stock, right? So let's do it this way. Similar to what we have, the 2, the 12, right? And whatnot. Let's say that the company pays a current dividend of $2, similar to what we had a while ago, and has a growth phase, right? Wherein the dividends will grow 20%. So not 7%, but 20% in the next 3 years. After that, so it's not a constant growth, right? But it's actually a variable growth. So 20% for the first 3 years, and then after that, it will have a stable rate of 5%. The required rate of return is actually 10%. So how do we calculate that? So we'll just do this one first as a scenario. Again, what are we looking at? Is scenario number 3, wherein there's a variable growth on the stock. What we're trying to solve is that what's the amount of the stock that has that variable growth? So we are all concerned about the dividends. Have dividend 1, 2, and 3. I start at $2, and then I know it's going to increase by 20%. So that's why I need to multiply by 1.2. So basically, 100% plus the 20%, sorry, is equals to 120%, which is actually equals to also to 1.2. That's why you have the 1.2 here, constant, right? Why? Because there will be a 20% growth in the next 3 years. So 1.2, 1.2, 1.2. So the way that we represent it in math is that $2 multiplied by 1.2, and the same dividend now, because it's going to grow, right? Multiplied by 1.2 will be 2.88 on dividend number 2 or year number 2. Then dividend number 3, pulling out from dividend 2, multiplied by 1.2 is equals to 3.46. Now, on dividend 4, so here, dividends will now grow at a stable rate of 5% after the first 3 years. So on dividend 4, and in perpetuity in the future, that amount that we have at 346, which came from dividend year number 3, will now have a growth of 5%. So I'm going to multiply that with 1.05, right? So basically, that's 3.63. I will now calculate. So let me explain this one. So remember, this one will be in perpetuity, right? Like that. So that's why we call that a terminal value. It's similar to what we did before. D4 now, 3.63 divided by 10% minus the growth rate. What's the 10, which is the KE? 10%. What's the growth rate? 5%. So that's why this one is 5. How did we get 5%? Is here. How did we get 10%? Is here. So the terminal value is actually 72.68. Let me stop there for a while. What we've been computing here is the price of the stock. That is similar. Or actually here, similar to this one, because it's the price of the stock. Forever, right? But in this case, it's 72.68. But that's a terminal value. I could not just stop here because I know the first 3 is different. The fourth one will be now perpetual. So that's why I need to calculate first the terminal value. I'll park this one, okay? Where did we get it? It's actually on dividend on the 4th year divided by K minus G, similar to what we had on scenario 2. Now, I now have a present value of the dividends calculation. And what was that? each one here is out here 2.40, 2.88, and 3.46. D1, D2, and D3. I multiplied with the present value factor. How did I get that? Basically, 1 over 1 plus I to the nth power. The nth power for now, I just did it by caret 1, caret 2, caret 3. Caret means that it's actually the keyboard expression or in Excel when you actually use that. If I place here 1, 2, 3 as years, I can actually do this as a link, this formula, and it will be the same. Enter is the same, right? So for now, I'll undo it. So when I give you the file, you can play with it. So 1, 2, 3. And then from here, you multiply it. A times B is equals to C, which is the present value. And then here, I added D1 to D3. That's now the present value of the dividend. Now, I need to discount the 7268, which is a terminal value, with the same third year calculation on the terminal value, which is actually the same factor here. When you take a look at it, it's the same. Let me make sure this one is the same as this one. If I multiply both, it will be $54 and then 53 cents. Then I add, then that will be the current value of the stock. A bit longer compared to this one, this calculation, or using this formula, because your dividend is not constant. So what's the name of the game? We need to actually have two phases of calculation of dividends: the high growth and the stable growth. The high growth, I need to calculate first. The stable growth will be for infinity, a terminal value, discounted on the third year, depending on the number of years on the high growth, and then added across as after discounting, then that will be the dollar amount. So variable growth valuation accounts for companies that experience multiple growth stages. It's a more flexible model than the constant. The constant DDM is actually the dividend discount model. Dividend discount model, DDM, because it reflects real world scenarios, and then where companies grow quickly in early stages, but will settle in the slower growth goes high, and then later on will stabilize, so it's a lower rate, right? At 5% compared to 20%. So that's our example. So it's a more realistic approach in valuing companies. So now when you think about it, if you believe that a company has certain stages, you use this formula, then now you would say that the value that you think of that stock is actually, in our case, $61 and then 69 cents. Now, for your quiz this week, it's mostly on stocks, which is good. That's why bonds is a refresher. When you think about it, it's a refresher of the present value formula. On the stocks, it's a bit different. It's just dividends divided by the rate of return. If there's no growth, if there is growth, then rate of return minus K minus G. But if it's multiple growth, then you actually have a two-stage calculation, like what we did on number 3. And then the other formula that we need to remember is actually deriving KE by doing D divided by P plus growth. So simple enough, a lot of calculation when you think about it. Hopefully the knowledge that you gain here, we will add again when we go through chapter 12, as we go through a project already. So, and then as we introduce weighted average cost of capital. So we'll try to make it as simple as possible, but we'll show you some real world application also as we go through. So almost there on building the blocks on a final capital expenditure project calculation. I know we're building a lot of fundamental or core concept in finance, but later on you would see all the application. So that will be the end of our video for today. So it's basically video one bonds, video two is actually on the stock, and then don't forget to answer your quiz. Thank you, everyone. Have a good night.